Hi, we're going to do our last question, question 11, and it's also worth 11 marks. That basically means it's 10% of the entire paper. We're going to cover qualitative analysis, that basically is our test of ion, cation, flame test, as well as a little bit of calculation in terms of calculating water of crystallization. So 11 marks, let's dive in. So let's understand the context of the question first. We have got a substance, sodium sulfate, and this teacher found unlabeled water containing this white solid. She just want to confirm that this white solid is sodium sulfate. So when it comes to qualitative analysis, what we can do, or what you should do, is you need to speed up the cation, the test of cation versus the anion. So cation, if you are not sure, is the positive ion, and the anion is the negative ions. Okay. So for the cation is the first part. For sodium, we can use flame test. Okay. And what we get here is the yellow flame, and that shows us that sodium ion is present. Now, one of the most confusing thing about the flame test is the colors. While they are really beautiful, looks like a Harry Potter situation when you're doing your flame test practical, they can be a little bit confusing when it comes to the theory, the memorizing part. And I think, in my personal opinion, the one that's really hardest is between lithium and sodium. So find a way to remember the difference in color between lithium and sodium. I'm looking at the Reddit title, I'm laughing. My teacher cannot come up with any. Come on, guys, you can come up with your own mnemonic. I personally don't really have a mnemonic to remember the flame test. I do have it for my mental reactivity series, but I just base it on my interaction with it. I personally like the potassium lilac color a lot, so that definitely goes into my brain. For me, calcium, because it belongs to group 2, there are two parts to its flame color. We call it orange-red, so that's how I remember things, right? Copper is just unique, just remind me of Harry Potter, so it's that blue-green color. But the yellow sodium and the red lithium, that's one thing you need to come up with on your own. So I hope this dude here has come up with his own mnemonic before his iGCSE test. Okay, alright, so we're going to look into the anion part here. For the anion, I'm going to use yellow. Okay, so for the test of anion, the anion in this case is our sulfate, which is our SO4 2-. To test for sulfate, by the way, the purple color parts, right, are basically your marks. Okay, so if you have written this out and written the yellow flame out, you have gotten 2 out of 5 marks. So the other 3 marks goes into the sulfate ion. How are you going to score for the sulfate ion here? Is first, for any anion, okay, you always need to acidify, and the best acid, in my opinion, to use is nitric acid. Okay, to acidify. The bigger reason is because we want to remove any traces of carbonate ion, which can give us false positive results. Okay, so that's our 4th mark here. And then what is the final color? If you add nitric acid followed by a few drops of barium nitrate, besides barium nitrate, they also allow barium chloride. So alternative answers here, and you will get a white precipitate observed. Okay, so for the sulfate part, it's a little bit confusing, a little bit more steps, because you need to first add the acid to acidify, then you must identify the correct testing, what we call testing reagent, and then finally tell us what is the observation if you have sulfate ion present. Okay, so the positive observation would be white precipitate is formed after you add barium nitrate. So that would be our 5 marks, half the marks here. Okay, and then the last few marks is all on calculation, and you have done this before, I would say quite a few times. So here we are trying to find the value of X, basically how many moles of water surrounding this Na2SO4. So how many moles of water surrounding it? So we're trying, that's the aim of this practical. So with this, there's always data in terms of numerical data. So first thing first, you have the empty crucible, you have got this mass, then you have a crucible with the hydrated salt. Okay, so from here alone, from the first 2 data alone, you'll be able to calculate the mass of hydrated salt that's added into the crucible, which is 3.22 here. And then you're going to heat until you get, see, constant, heat until constant mass. Heat until constant mass. This is a really popular question to be tested in terms of practical skills. How do you know that the reaction is complete? Well, heat until constant mass. That basically is the way to go. Why is it that I can't write? Okay, heat until constant mass. Okay, so with that, you will be able to actually identify what is the mass of water that has been heated off. So if you are left with 2.44 at the end of the day, or when you start with 26.79 gram, then you will know that the mass of water that has been heated off is 1.8 gram. So these are the two main calculations over here, part 2 and part 3. Okay, so I am just going to put it there. And again, yeah, see this is the question. How do we know that all the water has been removed, right? You want to heat until there's no change in mass, or you want to heat until the mass remains constant. Again, this is a practical question. While this is a theory, if you are given a chance to repeat this experiment or do this again in during your revision period, do this until you are able to attain this, so you will be able to first recall it better. And then number 2 is it justify why this is the correct answer. Okay, so I'm not going to talk too much about point 2 and 3 because this is what we have mentioned earlier on, how we calculate the mass of the anhydrous. Anhydrous means no water molecule. Okay, no water molecule left, and then the mass of water, we have mentioned it earlier. Okay, so the last 3 marks here is to calculate the X value in this formula. What is this X value here? So you need to use the mole of water. You want to calculate the mass of water. Okay, so the mass of water, again, I'm going to try to draw out my triangle for mass, mole, and then MR. Okay, in order for us to do this question, we want to find the mole of the acid and find the mole of the water, and then we compare it by ratio. Okay, so let's get started. So the first thing you want to do is to find the mole of water. Again, if you want to find mole, you want to use mass, which is calculated over here, divide by the MR of water, which is nicely provided, 18, and you end up with a 0.1 mole of water. Okay, then you move on to do the same thing for salt. The salt here is sodium sulfate. MR is provided, so this is the MR. Okay, again, if you want to find mole, you want to use mass divided by MR, so the MR is at the bottom, and the mass is over here, 1.42. Very nice, you get 0.01. The first few times I do this kind of question, I was so confused by the number of 0, and it looks like it's the same thing. It feels like the ratio is 1:1, but actually it's not. So take note of the decimal point, it makes a lot of difference. Okay, Na2SO4. Okay, and then finally you want to calculate the X, the ratio, basically how many mole of water is surrounding the salt. Okay, so you put the mole of water over the mole of the salt, and you will get a very nice 10. So what this means is, surrounding this sodium sulfate salt, you actually have 10 molecules of water. That's basically what it means. Okay, I'm not going to draw all 10, but visually this is how it looks like. Okay, so there we have it. All 11 questions done for 2025 paper 1. Again, just want to emphasize this is the regional paper. If I have time, I'll probably want to do the center as well. So if this has been helpful, drop me a DM, give me a like, say this is awesome. This will really motivate me to do paper 2 as well. If this has been helpful, again, like, subscribe, and share with a friend that would find this really useful for revision. Alright, if it's all good, see you!